All right. Sorry for the late start today, folks. um, it's been an unusually busy day, and it's just I just knew it was going to be kind of one of those things where I was looking at my schedule for today, and I was like, "There's no way things are going to run on time." So appreciate everybody's patience. And yeah, let's get going with some stuff. Give me 1 second to just kind of get oriented here. Um, I just got back from a very well. I've been here, but I just finished eating lunch really quick. That's why I needed the extra time because I'm going to be teaching till 10 p.m. my time, and I'm like, oh, this is my one opportunity to eat for the day, so I needed to squeeze something, and we will be getting started in just like a minute or two. So just hang tight, and yeah. Okay, cool. Looks like we're starting off with a few questions here. I do see a question regarding Bayes' theorem. Um, I would be happy to sync up with you and take that offline. Um, as of now, that is. I'm not going to say it's unimportant material. Um, it's not on the TI, and I'm trying to keep things oriented around like material that's pretty directly relevant to the TI. Beginner, intermediate, Python mostly. I'm willing to dive into stats on my streams on more in the sort of higher level senses. I think Tovio is willing to do more stats questions. You can DM me this question if you would please DM me a link, and I'll sync up with you after this. Or you can DM Tovio, and they will help you as soon as they can. So I'm gonna forego that very first one. Hopefully that's all right. Um, okay, yeah, sure, cool. You're welcome. All right, so we have a couple more questions, which is great. That's great. Yeah, and do feel free if anybody's got any. I know I'm like putting some constraints on it, but if you have beginner or intermediate Python questions, do feel free to put those into Slack. And yeah, I mean, if I have too many questions, that's a really good problem for me to have. If I have like 4 or 5 questions to go through, I'm like, okay, we got energy, and we're gonna be good to go. It's a totally doable thing. So looks like we've got one with the first challenge in this link. Okay, let me see. Let's see where this one's at. This is in importing. Okay. Okay. Okay, so this question, or this person is has a question in regards to this first problem in at this link. I think it's this one. Let's see. This is yeah the Euclidean distance function. So they're saying I can't seem to find a good way to iterate through each of the lists and the indices of the values. Aha, I can help you with that. We'll just do a Python. So this is the code provided as they provided it, and it is in a formatted code cell, which makes it easy. Thank you. So I'm just gonna kind of go through this like I normally would with any problem. I like to bring in my problem statement into my editor so I can mess with it. And I'll see if I can eke out a test real quick or find something maybe that jumps out at me. So before I do this, actually, let me just let me do a quick sanity check. Oops. 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 Okay. Try this again. There we go. Okay. That's called a sanity check. I'm just like printing something off just to make sure that my environment is all plugged in and working correctly. You'll see me do it a lot because I've learned the hard way. Okay, cool. So let's make some call to this. Print ucdist will take in, I'm just going to call it L1 and L2. I see the parameters list 1 and list 2, so presumably these are going to be lists. And let's go through this. So there's a link here. We'll kind of look at this link too. So complete the function called ucdist. I'm going to turn this into, so real quick, you're going to see me do this a lot. I try to showcase this. When I'm going through, excuse me, when I'm going through a problem statement, I'm trying to parse out information, oops. I'm trying to parse out certain information. So what I really want to know, you can remember IPO, input, process, output. Really, I and O go together. I mean, obviously input, output, right? I always just remember it as IPO. But what I'm basically looking for is, we'll say, process. This is like a description. This is a description of like what I'm supposed to do for this function, like how I can go about, or what I must or mustn't do in solving this problem, or a description of the problem. Maybe it's a specific problem, it has to do with a specific scenario, story problem, or maybe it's like implement this formula, or you know, process this data in a certain way, right? So it's pretty generic, just a description of the process. So that's process. I'm doing that first in this case, and then parameters, inputs. Let's do this. And returns. Return, which is output. In the context of a function, that's an output. Okay, so I'm trying to find information and like kind of sort it into these categories. With inputs and outputs, or parameters and returns, I want to take note of my type, and I'll usually annotate type in angle brackets like this. So if this is going to be a string, I'll just put or I'll put stir in angle brackets like that. You don't have to do it that way. I do it that way because there are languages where you have to specify type explicitly. They're called statically typed languages, or strongly typed languages. So there are other languages that use this as a convention so I know what it means. And it's a somewhat of a universal way of annotating type because of that. So you can, just as long as you're noting it in a way that makes sense to you, um, that's what's important. So right out of the gate, I can tell this takes two lists, right? So I'm going to say list one. Whoops. I'm just going to do this. List one is a list, and a list is a list of stuff. So I'm going to say it's a list of numbers. I don't know if these are ints or floats, so I'm just going to say numbers. And list two. Boom. Okay. And then the output, I think, is just a number, but we'll get to that in a second. So complete the ucdist function. This function calculates the Euclidean distance between the first list and the second list. I always like to bullet things just so there's like one item per bullet, kind of one sentence. The equation for computing the Euclidean norm can be found here. That's the link. I'm just going to get rid of this in this copy. Assume that two lists will be assume the two lists will be non-empty. Okay, we'll make that assumption. Note, although you can take the square root using this syntax, the square root function from the math module is preferable and significantly faster. Okay. So we'll import math and use the math.square root. Cool, there you go. So let's take a look at this old formula here. Make sure this is a good size. Actually, that probably does need to be a little bigger, huh? I'm like, why is this so big? And then I'm like, oh, right, because I probably was presenting last time. That would help. Oh, okay. Sorry, somebody's saying my audio is a little high. Oh, wow, it's super high. I'm not quite sure about that. Here, I'm going to turn my audio down. 1 second. Check, check, check. Okay. That's just avoiding peaking right there. Okay, that's probably a significant volume decrease. Sorry about that. I need to find a way to like make that more standardized. I play around with my settings. Yeah, that's okay. Hopefully that's better. Okay. Thanks for bringing that to my attention. Okay, so the person who's asking the question is saying, the code that they posted works for a pair of points in an XY plane, but it fails the test in learn because the problem tests for more than just 2 points. Yeah, so yeah, let's just dive into this a little bit. Euclidean distance. So I'm trying to find exactly the one. Two-dimensional, and I think this is Euclidean distance. Okay. This whole thing is Euclidean distance. I think this is n-dimensional. I think this is meant to be n-dimensional. Okay. So I think this is the formula we're going to need here, if memory serves. So it's going to be the square root of this P1 minus Q1 squared. So we can do P1 minus Q1 squared, and then add it to P2 minus Q2, etc. So let's do, you've got the enumerated and the zipped. Yeah. So I don't think we need enumerate for this one. Also, the way that this is written, actually, this is going to give us, oops. Okay, well, it's going to give us that error just because I because I tried to use variables that don't exist. Let's rectify that. And are there examples given? Oops. Let me see if there's examples for this one. No, there's no examples. Okay. Returns of floating. Well, if you look at that, I mean, I should have just looked at the. This is basically just telling me the doc string there, anyways. Okay, so the return type is a float. So we don't have an example with this one, but I'm just going to make something up. Let's just do 395 and 7. Okay. Excuse me. Okay, now we've got these two. So let's see. Oh, that's interesting that that works in that way. Oh, yeah, that makes sense. Okay. So one thing that I see that jumps out at me right away with this is your returning distance. I see two things. One is returning distance. You're setting distance equal in this case. But if you look at the formula here, this is basically a description of an accumulator pattern. If you look closely, right, you have this pattern of pi minus ni, or pi minus qi squared plus pi minus qi squared plus pi minus qi squared. Right? So if you abstract away that one, you just and replace it with I, right? You just the first element of p minus the first element of q squared plus the element of p minus the second element, etc. Right? So we're always squaring. So that plus needs to have, we've got to have a plus equals somewhere, which means we have to have this, make this exist ahead of time, probably at 0. So that's one thing. So I'm just going to do plus equals 0 for now, just to give that something to do. The other thing, actually, you're just going to try to localize this a little bit. The other thing is this enumerate and zip. Now, there are times to enumerate a zip. There are times when I've done that. I don't think we're going to need enumerate here. And if we look at X and Y, real quick, to the person who submitted this code and to anybody watching also, before I run this, think about what X and Y, what you expect X and Y to be. And obviously we've got multiple iterations, right? You might expect like 3 and 8, for example, right? Well, that's what zip is going to do. If this were just zip, that's what that would do. But since we're enumerating, X is actually going to be the index, and Y is going to be a tuple containing 3 and 8. So if I run this, oops. How is that tab error? What? Inconsistent use of tabs and indentation. What? Am I totally off here? Oh, I see. I see. Very, very tricky. Okay. This is not an error that I get often. um, tab error. So it's an inconsistent use of tabs and indentation. I'm wondering. If I do this, what do I get? Okay. Let me see if I can show what's going on here. I got to go into settings, and I have to make invisibles. I have to say show invisibles, and I forget exactly where that is. Invisibles. There we are. Show invisibles. All right. Aha. So I don't know if y'all can see it. Here's the thing. It's a really interesting error. So I'm going to paste this into Slack here. And hopefully you'll be able to see. It's subtle the way my syntax highlighting is set up. Hopefully you can see it. Hopefully it's coming through. Yeah, I'm going to try to blow this up so it's nice and clear. So if you look at this, and I didn't catch this because I have invisibles turned off, but you'll notice the indentation looks different when I show invisibles, right? Here's 4 like center dots, and here's 2 double arrows. I don't know why I'm trying to make the symbols with my hands. I don't know what I'm trying to do there. But here's 2 double arrows. So the double arrow tells me that this is a tab character, and the center dots tell me that these are 4 spaces. So Python, this is again, tabs and spaces are both white space characters. You'd think, oh, well, 6 and 1/2, it doesn't have the other, who cares, right? But Python cares. Python makes a pretty strong distinction between these 2 types of spaces. It is standard to use 4 spaces when you use an indent. So what I'm going to do is I'm just going to delete these tab characters, and then when I hit my tab key, my editor is set up to put in 4 spaces in a Python document rather than 1 tab character. There's this whole, you can get into, I mean, go do a web search for tabs or spaces debate. It is a heated world. It is people get very passionate about this, but Python comes down on the side of spaces, which is my preference as well. So remember to set that up in your editor environment to use spaces instead of tabs. Any modern editor will have that option. If your editor does not have that option, use a different editor. Replit has that option. VS Code has that option. I'm in Atom. This has that option. Jupyter Notebooks, everything should have that option. So interesting error, and it's something, I know it might seem like trivial, like it's not worth me like sinking into that, but yeah, it's those little kinds of things. I'm looking at this and it's saying inconsistent use of tabs, and in my head I'm thinking, oh, this is an indentation error, because sometimes depending on the installation of Python, the errors are slightly different. And then I was like, wait, no, I know my installation always says indentation error, not tab error, and I realized this isn't to do with indentation, it's literally to do with the tab character. Okay, so all that aside, we can get back into the thing, right? So x and y, if we notice, if I print out x is going to be my index from enumerate, and y is going to be the pair of elements in a tuple from zip, right? So if I wanted to actually pull this apart, where x and y were those elements, I'd have to do, oops, yeah, I'd have to do I, then parentheses, x and y like this. And that would successfully be able to pull apart that tuple with enumerate. It's a bit funny, but that's how you do that. For my code, I am going to call this P and Q because that's what they did. And we don't need to enumerate unless I'm mistaken. So let's just confirm P and Q are what I think they are. See, I do it too. Okay, so we've got P is from L1 and Q is from L2. So we've got 3 and 8, then we've got 9 and 7, then we've got 5 and 7. Okay, that's what we expect. Good. Oh, are you getting this? Oh, okay. That's interesting. That is very interesting. Huh. Okay. Somebody's saying that they get this error with tabs all the time when they paste in into REPL from learn. So that's interesting. I'll need to go in and make sure that all our spaces in learn or all our tab characters are spaces. Perhaps there's some errors in there. It's good to know. Okay. So P and Q, it's confirmed they are what I think they are, what I think they should be. By the way, every time you write a for loop, it's good to just, like, as soon as you write the loop, just print these out. Even if you think you know what they are, I mean, that's the point of printing them out, is to, like, verify that you, in fact, you do know what they are. So unless it's a problem that you solved before and you're kind of certain about it, or it's very similar to a problem that you solved before, you really want to print those out. And even if things go wrong, if you're in your loop and you're working through the problem and it's not doing what you think it should be doing anymore, the first place I check is, like, wait, am I sure that I know what my identifiers in my loop that I've created, am I sure I'm conceiving of those correctly? So that's the thing. And then from here, I think it's basically what you've got here. Math.squirt, and we'll do P, instead of doing list1 sub 0 minus list2 sub 0 squared plus da da da, I'm just going to do it. I need the element, so this will give me the elements, right? But what I want to do, these are the elements anyways, so I'm going to do P minus Q squared, and I want to square the whole thing, so I have to do that. Okay, so P minus Q squared. Oh, and I don't actually need the square root of that just yet. I'll do the square root down here. So this will just be plus gets P minus Q squared, and then instead of adding them here, I'm adding them here with this plus, right? So this is going to be P, so, list 1 sub 0 and list minus list 2 sub 0, square that, and then add it to list 1 and sub 1 and list 2 sub 1, square that, add it into distance, etc. Right, and then we should end up with this. And then once that's all said and done, then I'll take the square root. And if we look at the formula here, right, so all of this happens under the radical symbol. That's this check mark, big check mark, square root symbol, or excuse me, the radicand. So all of this is is happening together, right? We're doing each of these P1 minus Q1 squared, adding the whole thing, getting the sum of all of those, and then once we're done with that, we have that sum, and then we get the square root of that sum. So if I do this, oops, messed something up. Tab error. Oh, I missed one. Okay. Okay, cool. Let's just make sure that that's going to work as intended. I'll just pop that in down there and pop this in up top. And that's correct. And you can take a look at their example. I'm sure it'll be just the same thing with different names. Let's just take a quick look at it, make sure there's nothing wildly different about it. So they're just breaking this out into a different step, right? For I in range len. So this is the sort of your anything iterator here. Range len. You can do a lot of the like zip and enumerate and other the kind of fancy things that you can do in a for loop like this. These just make things a little more convenient, but range is really kind of the be all end all. Range and len, you can kind of do anything with range and len. For I and range len list is, yeah, it's a powerful construct. So for I and range len list 1, and the length of could be list 1, list 2, we're assuming that they're going to be equal in length. I don't think it says that in here. Maybe it should, but I think it's safe to assume for this problem that the lists are going to be equal in length, so you can take the length of either one. Then they're breaking out difference into a different step, but this is the same as just doing difference in line right here, and I think we need to parentheses before we do that, but you know, 6 of one, half a dozen of the other. The writer of this one decided to break this into a different step, which is kind of nice because it makes it kind of step by step clear, right? You get the difference, list sub I minus list 1 sub I minus list 2 sub I, and then you do your sum plus equals difference squared, the square of the difference. You add all that up and return the square root of it. And that's exactly what I'm doing here. So this is, I would say these solutions are logically identical, even though there was some different variable names and obviously slightly different approach with the range there. But yeah, cool. It's a good question. Okay. Feel free if anybody's got any follow-ups to that, like last thoughts, and then I'm going to move on. I know some other people have some questions in here too. I'll just give y'all a little bit, or just, well, there's kind of a delay between when I speak on stream and when y'all hear me, so I'm going to move on. But if you do have any closing thoughts or questions for that one, feel free to put them in. Okay, so somebody's asking, my first question is a bit broad, but it would help me in the long run. How do I utilize the Learn platform to get the best experience or most out of it? Is it read the text, click the replit, read the replit, then answer the challenges? I find myself not knowing the answer more often than not. And so I click on the video below and the challenge below the challenge and just copy what we all do. Yeah, you know, I think my personal opinion is, you know, if you don't, there's a stage of learning when it's just really helpful to see somebody solve the problem and give you the answer. So, you know, I want to kind of normalize that as a valid approach to learning this kind of material. You know, it can be really useful to see the answer explained and just shown. I think some people, you know, in a lot of other academic fields, that kind of thing is like cheating, you know. But I think it is a valid part of learning just to see. Well, I don't, you know, there's uh, like learning Python is an a posteriori um, uh, thing. It's a posteriori in nature, meaning that you have to you can't just look at the nature of the universe and derive Python. You could derive a logical problem solving structure similar to or the same as the one that you can employ in Python, for example. You could, you know, I don't know if that kind of, you know, we're kind of getting into philosophy now, but like, you know, you can make observations and come to conclusions about how to solve problems algorithmically. That's one thing, but Python is that plus just decisions on exactly how that's going to work in Python, right? It's a subjective thing. So, you know, there's the aspect of learning to program that is how do I solve the problems, and that's learning to like think through things algorithmically in a way that works um, in a programming language. And then there's um, just learning the language, like the details of the language. So that's where I think videos can be useful, right? Um, one thing that you can do, there were some studying techniques that I found very useful um, and continue to make use of um, as I learn other languages and even in, you know, honing my Python skills and stuff. Uh, it's actually, you get a lot of mileage out of solving a problem that you know the answer to. And it's, it's, I think there are other things maybe where that's not like that. Like once you know the answer, it's kind of a spoiler, right? But especially in the beginning stages of learning a new programming language, um, like memorize a few problems, like, you know, factorial. I'll show you. So factorial isn't terribly hard. We often use it as a sort of an example function because it's just got a little bit of everything. It's not terribly complicated. It's just got enough going on that it's sort of feels complete, you know, like, so this is simple, but I mean, even if you just like unfocus your eyes and look at the shape of this, right? It actually kind of looks a lot like this. You know, it's just an accumulator pattern problem, like a whole lot of things, right? So, I mean, you could do this with factorial, you could do this with Euclidean distance, you know, like find a few problems that you found interesting or fun and memorize them and um, practice implementing them smoothly, right? Like just going through. I'll actually show you. I didn't even do it with this one, but if I were going to practice factorial, right? I don't need to know how to solve factorial, but if I were going to like do a good like sort of practice of like problem solving practice for factorial. So I'm going to start with a test. I'll say factorial. Let me say factorial 4. Factorial 4 is going to be 24. Okay, so there's my test. Of course, I'm not discovering anything that I don't know how to do. Like I said, right? I don't need to figure out how to solve a factorial problem, but we're going through the motions, you know? Okay, so I have a test. I write my function stub. Of course, I expect none because nothing's happening. I'm just making sure that there's, you know, nothing's weird and I forgot a parenthesis or like I have a tab character or, you know, everything at this stage should be kosher. I'm not getting the correct result, but at least I'm starting from a good template. And then from here, I think I'm going to assume this is a accumulator pattern, and I'm going to accumulate on prod, and then I'm going to return prod. Just run it again. 1, that's what I expect at this stage. And then from here, I'll write the rest of the problem. So for I in range 2 to n plus 1, prod times gets m. I, like I said, I. Okay, run it. 24, that's what I expected. Okay, good. Right, so what I did was just practiced to reinforce a very simple but effective uh, beginner test-driven development workflow, right? And I say that because we've got the test here. You know, we stub out the function first, we check it, which is kind of like testing the test, making sure we're starting from a good place. Write in my accumulator target and my return right out of the gate. That way, as I work through the problem, if I ever hit a snag, I can see how, or I can monitor the thing that I'm accumulating on, which is probably the thing, usually that's the thing you want to return. If this had any edge cases, at that stage, I would handle my edge cases, you know, check all my edge cases, edge case tests, which this doesn't, so that doesn't apply here, you know. So things like that, like you're practicing, you're not only practicing problem solving, but you're learning syntax. And to help reinforce that, you can actually, it works wonders to just go through problems that you already know the answer to, because you're reinforcing syntax, you're reinforcing good workflow habits, problem solving techniques that'll help you with the harder problems. So that's something. In terms of like utilizing learn specifically, um, we've actually been talking about removing those replet links, because what we really want people to do is like have their own REPL and just kind of work out of that. So we've been discussing, and it's probably going to end up happening in probably sooner than later, is that we'll move away from those replet links and give you code that you can copy paste into a REPL. That way you kind of have to like engage with it and take notes in a document. Yeah, and the idea with that is we kind of want to encourage people to start working like this. Like you can see, this is my notes document, and I've got a few things up here like these functions I use frequently enough, like with students doing stuff, that I just have these quick reference so I can just copy paste them real quick. I have some text. Here's a clean text, which doesn't have any punctuation in it. Here's the same text with punctuation. And these are just if I want to play around with some text processing thing and I just need something to test on. So I have those. I have these little comment blocks. And then the rest of the document, line 86 forward, is all just stuff that I've done. It's just like every time I do a study hall, I stream and I take all of this code, I copy it and I dump it into my notes document. You know, so this might seem like a weird thing to do. It's funny though. This was when I started doing this, I feel like it really helped me study when I was a beginner. And I've done it, it turns out, my whole career to this point. And interestingly, Tovio did the same thing and said the same thing. We both arrived at this strategy independently of each other. So this can be a really useful thing. So this is not my only notes document. You know, this 5,000 lines of code is not all the code that I've written. On this machine, I have like 3 of these. Once I get to like 10,000 lines of code, I just archive it and start a new one, because a 10,000 line document starts to really slow down my text editor when it's just sitting there open. So I'll just dump it into another file and then start another one. So I've had this computer since April, and this is like my 3rd or 4th one. You know, of course I write a lot of code, and you might not fill yours up that fast, but yeah, we kind of are trying to push people towards a workflow that looks like that. The really cool thing about that is every time you make an experiment, you just stick it in your notes document, and you can search through that document. It becomes this like massive canonical history of everything you've done, you know, so it can be a really good way to work. So yeah, I don't know, those are just kind of my thoughts on it. I did want to mention too, in regards to our material, we often recommend folks like go to like Code Wars, or we're not like affiliated with Code Wars specifically. It's just like the service that Tovio and I think other people on our team just have the most familiarity with, and it's as good as any. There are other coding practice sites. I recommend go try a few if you want, or you can just go to Code Wars. Um, so I think our material is really good as sort of what I would say like rich documentation or interactive documentation for like beginner and intermediate Python in terms of the Python material. Code Wars is good for like pick a random problem and figure out what you need to do to solve it, right? Um, so that's, I would say, you know, our material is good for like you want to like figure out the concept. You know, like if you want to learn how to like um, add items to a dictionary, like our material is going to go through and explain something like that. Nothing in Code Wars is going to tell you how to add something to a dictionary, but if you want to start like playing around with random problems where you have to think, should I use a dictionary here, or a list, or should I use an accumulator pattern, or does this have edge cases, you know, like where you have to figure out what things you need to do to solve the problem, that can be a good place to like kind of bring things together and synthesize it together. And we're trying to push to like add some more elements like that into our own material, but basically that just means like developing a library of like thousands of questions that people can work through. So it just takes time. So that's kind of how I think about it. Like when you want to like learn the concept for the first time or reference like how to do something, our material is pretty good for that. The challenges in Learn are like, I think, often really good problems for like Euclidean distance. Like that's a good problem to like to memorize and make like a, you know, turn this problem into a form that you practice, right? That you can kind of practice going through the motions of this. So you write your test, and then you go through the motions. You know, I know I'm going to want to import math, def, right? And the cool thing about this is like, you know, you might wonder, oh wait, does this need to be the same name as this, right? Well, this is a great opportunity. This is kind of undefined practice time, right? Like this is a great opportunity to figure that out. Like, okay, if I do this, what happens if I print L1? What happens if I call this poodle? Poodle. Oops. I literally didn't mean to type that. Poodle feet or something. Um, L1 is not defined. So if I call that list poodle feet and then print that off, it's going to work just just the same, right? So this is a good opportunity to kind of like go through and like you have this undefined practice time where you can kind of like explore and figure out how to get Python to answer your questions for you, you know. And I think that's where the real skill of programming lies is like getting the, you know, like you will reach a point someday where you realize like, oh wait, I can get the language to kind of teach itself to me. I know enough now to like know how to ask Python and get it to tell me what things are and what things are possible and what things aren't possible and what my options are and things like that, right? So this is kind of you're practicing exploring, you know. So anyways, I know that was probably more of an answer than you were wanting from just like how do I use learn. But yeah, I mean, I guess the short answer is I think our material is good for like interactive documentation when you're learning a first concept, when you're learning a concept um, for the first time. Um, it's a good place to go back and reference things. And the questions that we have, I think, lend themselves well to doing this kind of practice. Which, yeah, hopefully that's clear. Okay. I'll move on at this point. Okay. Let's see if we got more questions here. Oh, somebody's asking about challenge 3 on that prior page. I think it's just this page, right? Okay. Oh, interesting. Yeah, it sounds like, yeah, so somebody's saying, what about question 3, which is here, and they're saying that the way the formula was written is confusing and that there's something with backslash c dot. So what you're seeing is actually, I recognize that backslash c dot as that's raw LaTeX. LaTeX is a you've probably heard it. You've probably seen it spelled latex. Um, you've probably seen it spelled like you usually see it written like this: capital L A, capital T E, capital X. This is the canonical spelling for that. Just is annoying to me that it is spelled that way, but um, it's spelled with alternating capital letters. It's spelled latex. It's pronounced latex. Go figure. Um, so it might be something that you're familiar with or you've heard of. It's a uh, kind of a mathematical markup language, and it's what's responsible for this right here. So sometimes that sounds like you encountered a rendering error. Like we probably didn't go update it between when you saw it the first and the second time. It probably just sometimes that happens where your your browser won't render something correctly for whatever reason. If you've ever gone to a page and you just get like a raw HTML page, it's the same kind of error. So that seems like what probably happened there. We have had issues with our LaTeX rendering system lately. So yeah, if you see something and you see a formula and it looks just wrong or somehow uh, really weird, then probably reload the page and that may fix it. Yeah. Okay. Cool. All right. I'm just kind of going through here. It looks like somebody had a question about the star equals, but there looks like they had to jump off to run some errands or something. Yeah. I suppose the floor is open for questions if anybody's got anything. I'll give you all a minute to get something in, and if not, I will find some material and we'll just go through that. All right. Sorry about that. We've got a question in here that involves explanation of a. This is a two-parter. It relies on a question from the previous one. I've taken this on stream, and it's a long one. If you want to DM me, I will sync up with you after stream on this combinations question. Okay, cool. I think let's pivot and move into some. Oops, sorry. Let's move into going through some of the material here. We've only got 15 minutes left. This section's on variable scope. It'll be something light to cap us off for the day. So we're pretty early on in the material here. This is at the end of the lesson on variables. So variable scope, this is an interesting one. This is going to talk about functions a little bit. So let's look at some examples of what's meant by scope. So if I have a variable, if I just say a equals 10 like this, a is this is a global variable. I mean it's available in the whole program. Well, everything after line 68. If I try to access it before, then it doesn't exist, but that would give us an error. So if I try to run that, it'll say name A is not defined. But I can do that. And this is what's called a global variable because at least after it's defined, everything has access to it, including if I say def my function, and I'm going to write a function that doesn't take in any inputs. If I say return a plus 5, okay, so this is going to work, but I want you to take note that this is something you should never do. Specifically, what you should never do is write a function that just out of nowhere uses a global variable. If your code has global variables in it, which it probably will, at least the way you're coding right now, kind of the way that we're teaching, your code will probably have some global variables in it. You might think, well, you know, I have to use a global variable in my function because, like, how am I going to get it into my function? So if you have a global variable and you have functions, there is one legitimate way, one and only one legitimate way that that variable should be inside the function. It should go in through the front door, through the parentheses, right? So I could pass a in here, and I'll just call this sum variable. And then now I have to change this to sum variable. So this is okay. This is okay again. Now probably in my code, I will have things organized where, you know, the stateful data parts of my code, the parts that hold a state, are separate from the logical parts of code. You want to enforce a separation of logic and state. In a lot of workflows, in most workflows, you won't just have like variables and function definitions kind of thrown in with each other. You'll have a place where your functions are defined, and then a place where your stateful elements are, and they will utilize, that place will utilize the functions that were defined somewhere else. That's generally how most things are going to be structured. So let's go back to why this is not a great idea. So if I have this function, right, back to having no inputs, and we just return a like this. If I run this, this function appears to do what I intended it to do. A is equal to 10. We return 10 plus 5. So that's fine. So what happens if I say A equals hello? Think about this. Before I run it, feel free to, like, you know, just think about it for a second. Don't, you know, hypothesize what might be the behavior. You know, you might be able to think of a couple things that happen here. I can think of a couple things that could, that, like, you know, if I'm just saying like, oh, you know, maybe it works like this, or maybe it works like that. think about, of those things that you can think of, think about, is there one behavior that's better than another? Or is there, you know, are they all bad? Is it desirable behavior? Is it something you would ever want to have happen? Each of those, right? Each of the things that you could think that might happen here, right? So one thing that I could think might happen is, well, a equals to 10 at the time that this function was written, a was equal to 10, so that this is essentially just canonically written as 10 plus 5, and this is always just going to be 15. But that's one thing that you could think might happen with this code. Another thing that you could think might happen is we change it to hello, and then this is going to go look for a variable called a, and it's going to find this variable, and it's going to try to return hello plus the integer 5, which is, you can't add an integer and a float, excuse me, an integer and a string together. And that second behavior is what happens. If we actually look up here, right, this first function ran just fine and gave me 15. But the second one, I get a type error, can only concatenate stir, not int to stir. So it's saying it doesn't know how to add or concatenate an integer to a string, which is fair. I don't really know how to do that either. So this, what has happened here, and I've used an intentionally very small example. What has happened here is that I defined a function and changed a global variable, just a random global variable, and it has broken my function forever. Every call to this function henceforth is now broken. Every call after this change is broken, right? So I would have to go like fix that, right? And I've used an intentionally simple example, and you can even see it's a little convoluted, right? Like you might be like, I understand very well what's going on here, and yet I feel like I have to do just a little bit of juggling to keep things straight in my mind. Look at how bone simple this function is. It doesn't even have an input, right? Imagine if this was any more complicated, let alone imagine if this error occurred on some some function in a document that's several hundred lines long in a program that has several 10 or 15 Python files that are each a few hundred lines long. You know, good luck tracking that one down, because all you've got to go on is this type error. You know, you might be able to use the stack trace to help you track it down, but yeah, that can be a difficult error to deal with. So the solution is never do it. The solution is never write a function that just out of the blue uses a global variable. You might think, well, you know, if I have this function, right, I can just use this function in another function like that. That's totally fine, and it is. And the reason for that is functions are constants. They don't change. Their outputs change depending on their inputs, but anywhere where you're calling the function, where it evaluates to that output, you're handing it inputs, right? So it's still possible that maybe you handed it the wrong inputs, and in this case, it doesn't even take inputs, doesn't even take parameters, but it's possible that you could misuse this function. You know, what I might want to do here is I might want to define an input here, and then I could pass a, right? And now I still have one call to this function that works and one call that doesn't. But in the call that doesn't work, it's just the one call that has a problem, right? Like, so it's still possible that, you know, you could call the function with an input that doesn't work or that's going to cause an error, but it's not going to break that function forever. It's just going to break it in that one place, which is nice because then you only have one problem to deal with, not many, you know. So, and the solving that problem involves working here, right? You know, maybe I'm like, oh, you know what? I don't want to pass a, silly me. I just wanted to pass the length of a since a is a string or whatever. Now that works. Okay, that's fine. You know, maybe that's all I wanted to do. So in this case, you can think about it. When I figured this out, I put it in terms of like the front door and the back door. So you think about the function. This is such a silly analogy. Think about the function like a restaurant, right? It's like a restaurant's kind of like a function. It has inputs, which are the customers, and it has outputs, which are the meals. I don't know. That's a way to look at it. There's probably other ways to look at it too. But so you can think about like um, there's certain things in a restaurant that are allowed to come in the back door, right? The employees, the produce, you know, like the food. You take the trash out the back door, but the back door is not a customer entrance, right? The front door is that's where the customers come in, right? So you think about like the variables as the customers coming into the restaurant, right? Um, so whenever you have a variable, since variables can change, you want to pass those in through the parameters in the parentheses. It's okay for them to find their way into the function, but the only way they should find their way into the function is through the parentheses. Now, of course, you know, maybe I wanted to create it inside the function. That's another option. Um, maybe that's what I wanted to do this whole time. So that's another thing you might consider when you're thinking about I have a function and I have to make this variable. How should I approach this? You can create variables in the function, and you can pass variables into the parameters. If you're looking at your function and you're like, well, I have this global variable. I know I don't want to create it inside the function, but my function only takes 2 arguments and they're already fulfilled. How do I get this variable in my function? Well, unless you're solving a problem that says this function takes in 2 variables, if you're writing the function, if it's your code and you're inventing how it's going to work, that scenario tells you your function should take in a 3rd argument of some description, right? So if it's currently taking in 2 and there's something that needs to get inside there, that's a global variable, and you know it needs to stay a global variable, then write your function to take a 3rd argument. If there's other places where that function's already being called without that 3rd argument, then consider defaulting that 3rd argument to something so that it'll pass on the ones where it's not getting that 3rd argument. So that may, you know, tell you need to rewrite your function a little bit, or maybe rethink how you're doing things. So yeah, those are just some tips on working with global variables. I'm surprised that took me 15 minutes to get through all of that, but I think that's a good place to um, wrap up for the day. I'll probably, you know, next time I go through material, I'll probably go through this again because even though it's kind of basic, this I know it's a little bit tricky, and it's a really important, really important thing. Um, if you're writing, and I've done this when I was a beginner programmer, and I wrote a lot of code for some kind of beginner projects that I was doing. Um, and I just didn't even think about it. I was just like, oh, well, I've got variables. I need to use those variables in my function. I'll just use those variables in my function. I didn't pay it no mind. I didn't think about it twice. And I just I remember getting, like about a quarter of the time that I spent, the first 25%, after that first 25% of time that I spent on that project, everything after that was just like, every time I would change anything, it felt like I would just like introduce like this huge train of errors, and I would just have to go backwards through the whole thing and scrub out each error individually. And I just had this this mess that somehow when I needed it to work, it worked, which was basically a miracle. Um, I don't know that I could go look at that code today and make sense of it. Um, but so I learned the hard way. So you don't have to, unless you insist upon learning the hard way, which maybe you will, and that's okay too. But yeah, so you want to watch out for global variables. The key is either pass them in as inputs, create them inside the function, or find something else to do. uh, cool. All right, I'll wrap up there. It was a pleasure. It was a fun study hall. Um, sorry about not taking the stats questions. Do feel free to DM me those if you want, and we can sync on those uh, after this, or at some point later in the week, or bring them into Tovio's stream. I'm sure Tovio will be happy to take those as well. Yeah, if you're in premium prep, I'll see you in about an hour and a half. And if not, then hopefully I'll see you later. See you in another study hall. Cool. All right, I'll wrap up there. You have a good day. Bye bye.